Okay, now we are working on an optimization problem, and we will use our calculator eventually to work to help us evaluate the answer. So we have the volume of a cylindrical can of soda to be 40 cubic inches. And the volume of a cylinder is the area of the circular base times the height, and we've been told that that is 40. So we're actually going to use that to write, let's do H in terms of R, which will make our lives a bit easier. So we have H equals 40 over pi R squared. We could have done R in terms of H, but then we would have had a square root in our equation, and that would have made it more difficult. So that's why I chose to solve for H in terms of R instead of the other way. Now our goal is to minimize surface area. So I need the equation for surface area, and I have each circular base as pi R squared, but I know that I have two of them, so I have 2 pi R squared for the two ends, and then I add to it the area of the sides, which is the circumference of a circular base, times the height. So our job is to minimize this surface area, and you can see that it's helpful that I solved for H because I can take what I have for H here and plug it right in to the one spot that we have H. So I have surface area equals 2 pi R squared plus 2 pi R times, instead of H, I'll put in 40 over pi R squared. Now, what we want to do is take the derivative here and then set the derivative equal to 0. So let's pull up our calculator, and what I'm going to ask you to do is go to the y equals screen, and I'm going to have to clear out what I have from the last time I used the calculator. And in our y equals screen, we're going to put in this entire formula for surface area. We're going to use x in terms of r because the calculator won't take an r. So we do 2 times pi, 2 times pi times x squared, add to that 2 times pi times x, and then open parentheses, and you'll have 40 divided by, and then make sure you put the entirety of pi x squared in parentheses so the entire thing stays in your denominator. So do you see how I have pi x squared in parentheses in the denominator? Then I close that. Okay, so now what I want to do is find the derivative of this. Let's just go make sure that I have the right equation. 2 pi x squared, 2 pi x, and then 40 divided by pi x squared. Okay, that looks good. Now, I want the derivative, and I want to know where the derivative is equal to 0. So what I'm going to do is have this graphing calculator take my entire derivative. So I'll go to alpha, F2, and remember choice 3 is numerical derivative, and I'm differentiating with respect to x, and I'm going to differentiate the function in y1. So I go to alpha, trace, and I choose y1, and then I want to do it for all values of x. Then I only want to see the graph of the derivative. So I'm going to come over here to this equal sign up in y1 and hit enter. So you'll notice that my equal sign is not highlighted under y1, so that graph will not appear. And I don't know what window I need, so I'm going to do a zoom standard, zoom 6, and we're going to see what comes out, and I probably have to change my window, particularly if I get nothing coming up. Actually, look at that. I have something coming up. And I don't really need to see the whole graph. I was thinking I might have to change my window because I know that my x value, which is the radius of the cylinder, has to be positive because I can't have a negative radius. But look, I have 1, 0, and this is probably what I need. So I'm going to just go what I know from Algebra 2, second calc, choice 2 is 0. And my left bound says that x equals 0. That sounds good to me. Whoops. Lost my graphing calculator over on the other side. Sorry about that. Now I'm going to go to right bound. There it goes. Now I'm at positive y values. So I hit enter and guess. And it tells me that my radius is going to be 1.853. And please remember that you need 3 decimal place accuracy for everything in AP Calculus. So they asked us the dimensions. That means my radius is 1.853, and I need to plug that in to my height expression in order to get the height, because they want both the radius and the height. So in order to plug in, I can just come back to my home screen by hitting second mode, second quit, and I could do, let's see, 40 divided by, oops, missed the divided by pi, and make sure you put this denominator in parentheses, but pi times, and then 1.853 squared. And close parentheses, and we will get 3.708 is the height. And that's how you use the calculator to help you with this problem.